So in this class, my dear, I'm going to discuss problem based on collision. Right. So actually, student, this is the request by student. Sir, please make some live class for collision here. So now, students, I'm going to start the class for today. So this is students. Okay, in this lecture, just I'll tell little point about collision. So what's a collision here? I can say all of you remember. Collision is what, my dear? Collision is what? Transfer of momentum due to only internal forces. What, my dear? Collision is the transfer of momentum due to only internal forces. Right, my dear? Okay. So beta, from here onwards, we'll go through. Means I can say here, a student, I'll not much discuss theory. Right. So we'll go through a direct numerical lecture. Yes, beta. We'll go through direct numerical here. Okay. So come to the point, beta. This is the first numerical here for the class. If there is a requirement of any beta theory points, so I'll discuss. So beta, I'll discuss here those points also. So let's begin with the. This is the first numerical lesson for today class. So what question says a pendulum, students, a pendulum bob of mass. You can take it in consideration like this. It's normal question. I'm not telling any question from anywhere. Okay. You can take as a consideration a pendulum bob of mass 10 to the power minus 2 students kilogram, right, is raised to a height student, that is 5 into 10 to the power minus 2 meter, and then released, right, at the bottom of its swing. At the bottom of its swing, it picks up a mass. Okay, that is beta mass picks up here. This is water, students. Student Jai Shri Sham. Student Jai Shri Sham. Okay, this is what beta minus 3 kilogram, right? To what height will the combined mass rise? Okay, so listen carefully, my dear. How this is? Question here, listen carefully first. A pendulum bob of mass, this is raised to height this much. Beta, I'll make diagram here for better understanding. You can easily understand, my dear. This is step one for these questions. Let us suppose this is initial position of your pendulum. Beta, this mass I'm calling M1 here. This mass I'm calling M2. Right. This is M1, my dear. This is what? M2. Okay. This mass beta, let us suppose beta, I can say battery discharge. So I have to remove this one. So beta, this is initial mass over here. Now beta, there is some height here. Means you can say M1 block finally arrived. You can say at this height. Height is mentioned 5 into 10 to the power minus 2 meter. This is the height beta. This is mentioned in the questions. After, let us suppose if once M1 block is here initially, finally beta M1 block is here, right? Okay. Now students, here you released. This is M1 block at initial position, M1 block here student. Now here I released, right? If this block released, M1 block, so beta coming, because definitely you can say, sir, this bob coming back, right? So if this bob coming back, my dear, so here I lift up this much mass. Here what add on, you can say mass increases over here, right? So we have to find what is the combined mass, combined mass will rise up. That is a question, my dear. Okay,
So beta, what you can say, velocity of pendulum here, bob, at the bottommost point here, because you release from here only here, so there is no energy at all, kinetic energy zero. Particle has what, basically potential energy. So this energy what, converted in terms of kinetic energy here. So first we can apply beta from here to here, that is what I can say, energy conservation from this point to this point. So beta will get v1 here. So v1 beta we can write, this is 2 gh, velocity of pendulum beta bob at the bottommost point, right? So this is beta, you can see 2 g beta, you can take 10 meter per second for ag calculation, 10 meter per second students. So this is 2 beta and g 10 here, and what's the height here? This is what, 5 into 10 to the power minus 2 here. So you can see this is what, 5 into beta 10 to the power minus 2 here. So you can see this is what, cancelled. So finally which I can write here, v1 is equals to 1 meter per second. Keep in mind, this is the velocity of bob at what, bottommost point. This is the velocity of bob beta which I found after release here. This is what, v1 1 meter per second. Okay, when the bob, I can see better in the question mentioned according to questions. Let us suppose step 1 finished, my dear. Step 1 finished. Have a look step 2 students. So this condition what say, you can see mass beta they lift up here. How? 10 to the power minus 2. So beta, for this condition we can apply here entire body mass in motion only. So students should apply here, because this is again here I'll make one diagram. Let us suppose this is the block of mass which is 10 to the power minus 3. Now here I can see another block hitting over here. So we can see this is combined mass will move together. This combined mass what, student, will move together here. If this combined mass, student, will move together, then what you can say, we can find what is the combined velocity. So here we can apply our energy extremely sorry my dear, momentum conservation we can apply in horizontal direction, because this is the velocity we got, I can say, in horizontal direction, students. So you can apply over here what, momentum conservation along x-axis, right? So simply bacha, you can say m1 v1 plus m2 v2, because initially this mass at rest only, this mass at in motion bacha. So here is now I'm applying momentum initial is equals to momentum final. What's momentum initial, students? m1 you can say bacha e1 v1, don't worry, m1 v1 plus m2 v2, both mass will move together, students. m1 plus m2 into v, we have to find combined velocity. We have to find combined velocity. m1 bacha already we know here, v1 bacha we already found here. So you can say m1 is equals to 10 to the power minus 2, student, v1 is 1 here, plus m2 bacha 10 to the power minus 3, but you can see sir initially at rest. So this is what, v2 is equals to 0, my dear, which is equals to, I can write 10 to the power what bacha ji, 10 to the power minus 2 plus 10 to the power minus 3 into v. But here we'll get here what is the common velocity, right? Do one thing beta, just take your common 10 to the power minus 2 from here and just do beta, finish cancelling each other. You can take snapshot here, I wanted to turn the page. Okay, so now students, just I'll continue here, same thing. So this is what, my dear, 10 to the power minus 2 plus 10 to the power minus 3, which is equals to 10 to the power minus 2, but I'm taking out here. So this is 1 plus 0.1 into v, right? So here student, here this side also you need to take beta 10 to the power minus 2 common. So this is what, 10 to the power minus 2 beta, what we can say, 1 plus beta g 0.1 here, right? So finally bacha, what you will get here finally, this is 10 to the power minus 2 bacha, this is 1.1 here. So these terms is cancel each other. So v beta, you can write here in these terms, finally v is equals to beta 10 to the power minus 2 here, 10 to the power minus 2 upon bacha ji 1.1 here, 1.1 into beta 10 to the power minus 2. So you can say beta, this is finally cancelled. So we'll get here common velocity, my dear. This is what, student, common velocity here, 10 upon 11 meter per second. 10 upon 11 meter per second. Okay, we wish to find height here. So you can say, bacha, in step 3, I'm going to find here h max, because we have to find what's the maximum height combined mass will rise. So h max you can write, my dear, u square by 2g, and ub got. So you can say, student, h max is equals to 10 upon 11 whole square. 2 into you can take 10, bacha. So h max beta, what you can write here? This is 10 tens are 100 here, and 11 what? You can say 121 into 2 into 10, bacha, per day. So this is cancel here, this is cancel beta, this is what? 5 by 21. H max beta, what you can say? This is 5 by 121 meter here. Further you can solve. 5 by beta 121 meter here. So this is answer of the questions. Okay, student, if there is any doubt here, we write in chat box. Student, if there is any doubt here, we write in chat box, my dear. It's highly required here. Okay, student, move on next question here. Yes, beta. JE Advanced here 1984. Students, move on next questions, my dear. This is students JEE Advanced 1984. What, my dear? JEE Advanced 1984 here. So what question says, bacha? I'll read one question here. Listen carefully. Two blocks A and B of masses m and 2m respectively are placed on a smooth floor. Okay. So in step 1, student, first I'll make diagram. Right. So this is what, student? Mass is m. It's a spring here. Another block of mass already mentioned in the question, students, block A and B. So let us say this is block A, this is block B, my dear. Masses is mentioned, this is what 2m. Right, my students? Okay, two blocks A and B of masses m and 2m respectively are placed on a smooth floor. They are connected by spring beta. Already shown the diagram here. A third block C of mass small m moves with velocity v naught. Okay, so there is another block here, which is block C, mass is m, and this block beta in motion. This block in motion. This is, you can say v naught. This is what, my dear? You can say v naught here. Okay, they are connected. Mass m moves with velocity v naught along the line joining A and B and collides elastically. Okay, just keep in your mind, students, elastic collision. This is what, my dear? Elastic collision. I hope all of you remember your meaning of elastic collision. What you can say, there is no loss of energy, so you can also apply energy conservation if required. Right, students? Okay, elastic collision, students. Okay, with A as shown in the figure, at a certain instant of time t naught, after collision, it is found that the instantaneous velocity of A and B are same. Okay, further at this instant, the compression of the spring is found to be x naught. Determine. Okay, so bacha, this block will hit here. So there is a beta compression. So compression amount beta you can take in consideration. Compression. This is what? X naught, my dear. Right. We have to find here. Determine beta the common velocity common of block A and block B in time t naught, bacha, at time t naught, student, at time t naught. Next beta, in point 2, you need to find spring constant. Okay, again here I'm just going to recapitulate question again. There is a system which is, you can say, block A and B. both connected through a common spring. It's ideal spring. Initially, both A and B are at rest. Block C is in motion. Block C mass is equals to m. Block C is in motion with velocity v naught. Once this block will collide with, I can say, system A and B. So collision is elastic. After collision, student, there is compression which is equals to x naught. So we have to find common velocity of A and B in time t naught and spring constant. So let's student begin with I can say logic here. Solution of this question, my dear. Okay. So first beta we'll go through beta first part here. We have to find common velocity. That is very easy, pretty easy, students. Soon step 2 beta. This will go through because no beta it's collision elastic here. So you can think about first momentum conservation. You need to think about what first initially momentum conservation here. So you can write beta P initial is equals to P final. P initial is equals to what beta you can say P final here. So beta now this one thing also you can take in consideration. If this block C once will hit the system, then this will at rest and this will move. This will at rest and this will move bacha buddy. So what you can say bacha? P initial, this is what m into v naught remains at rest here this one. So you can say bacha 2m plus m into v. It's a common velocity, student. You can see this mass. Happy birthday each other. So you can write here common velocity which is equals to v naught by 3. Common velocity, students, you can write this is v naught by 3. Okay, so we got your answer first of the questions. You got it answer first of the question here, right? Okay. Next bacha ji, we'll go through is we wish to find spring constants there, so we can apply energy conservation. We don't have any options, right? So in step 3, students, I'm going to apply our energy conservation, right? So beta what we can say energy conservation here, system you can say which kinetic energy means energy initial is equals to what energy final. So we have initial kinetic energy students only, kinetic energy initial. We can write here kinetic energy final for block M, and beta you can say kinetic energy final for block 2M, plus here you can write potential energy final. What my dear? Potential energy final, right? Okay. So here bacha initial kinetic energy you can write beta half m v naught square. Kinetic energy final here both will move together only. So you can say bacha half 2m plus m beta, this is 3m v square. You can say v naught by 3 whole square plus bacha plus beta what you can say, because initially spring compressed here, so you can write half of k x naught square. Half of k bacha ji x naught square here. You can say first, sir, this half finished everywhere. This m also finished. No. You can't say finished because there is nothing here. So half beta finish here. That's it only. Just want to take snapshot here. I want you to turn the page. Yes, beta. So this is someone responded. Yes, beta. God bless you for your reply in live session. You are just replying things, but I'm feeling proud on you, bacha. So this is m into beta v naught square, which is equals to 3 v naught square upon 9 plus beta k x naught square. Right now, bacha? Okay, listen. You can see 3 3 is 9. So this is m v naught square. And beta missing over here. You can say m v naught square by 3, which is equals to kx naught square. So this is 2 by 3 m v naught square is equals to kx naught square, right? So what we wish to find here, just tell me. It's very constant. Oh, got it. It's very easy here. Pretty easy question. K beta what you can say? This is 2 m v naught square upon 3k. What my dear? K will get finally here. This is twice of m v naught square upon 3k, right beta? So this is I can say bacha for the questions here. It's not a tough at all. You can see once again if you wanted screenshot, then beta I can take it. Yes, bacha. So now beta have a look at next questions. Beta have a look at next questions here. Okay, we'll do beta question based on collision only here. Right. So beta, what's the next question? Have a look, my dear. So this is student. Again here, I'll read question once. Right. What is print? Two blocks of equal masses, capital I can say small m, are connected by an unstressed spring. Students, you can take in consideration here. This is the horizontal plane. M is what? You can say mass. There are two identical blocks connected to each other through spring. This is mass remains m. Applied force on I can say block, right side block beta, this is what F only, right? Initially beta you can take in consideration here K is spring constant, my dear. There is no stress at all. There is no stress at all. Okay, system at rest here on is frictionless. There is no friction. Student, there is no friction at all. There is students no friction at all. Right, a constant force F beta, force remains constant, is applied on one block, pulling it away from the other as shown in the figure. Beta, here we need to find displacement of the center of mass in time t. Student, find displacement of center of mass in time t. And second, students, the extension of the spring x naught at time t naught. Beta, you have to find here x naught and find the displacement of two blocks at this instant. Displacement also we have to find. In third beta, find displacement of given blocks. Find displacement of given blocks. Again, I can say it's a good question, my dear. So listen carefully here. Now, student, again I'm going to repeat. There are two identical mass block. Both are connected through a spring. A force is applied which is constant in magnitude on I can say right side block. Find displacement of center of mass in time t, because you are applying force regularly on a block, so there is extension, so you need to find beta g x extension in the spring in time t only. And last one, displacement of respective block in time t only. Okay, so now should begin with first part of the questions here in solution. Yes beta, this is step 1. Now I'm going to solve here. I can say part 1, displacement of center of mass. Find beta what I can say, displacement of center of mass here. So first I'll write expression of a student, acceleration of center of mass, which is equals to beta, you can say force total upon mass total. So acceleration of center of mass, this is F upon beta 2m here. Got it? So we need to find acceleration of center of mass in time t. So you can see bacha x is qm here. Now students, I'm going to use here, this is age remains constant, so I can use equation of motion second from kinematics. So x is qm is equals to what beta? Half of a qm, half of a t square, right my dear? So this is x qm is equals to half, and a bacha, this is f upon 2m into t square, f upon 2m into t square bacha. So finally you can also write bacha f into t square upon 4m. So this is what my dear? This is x qm. This is what my dear? X qm here. So I can see this answer of first part. In second part beta, we wish to find what is the extension in the spring here, right? And so beta, you can just take in consideration because we used to find beta, let us suppose I'm going to apply a XCOM. So what is XCOM bacha party? You can see here, this is, let us say, beta, if you are applying force on a block towards right, so block M beta move x1 and block 2 beta x2. So student, I hope all of you remember your XCOM formula, m1 x1 plus m2 x2 upon what, m1 plus m2, my dear. XCOM already I found here. So m1 x1 plus student m2 x2 upon beta, this is m1 plus m2. XCOM beta I can use from, I can see result which already I found in part 1, my dear. So this is f t square upon 4m. m1 remains m bacha party, x1 that I can take x1 plus beta, this is m2 remains m here, x2 beta I can take x2. This is what you can say beta 2m. You can easily say, student, you can easily say everyone, sir, this mass, happy birthday each other, right? So these two finish bacha, you can say like that here. So what will get here, x1 plus x2, x1 plus x2 beta, just take snapshot, my dear. Student, take SS. Okay, now beta, just I'm going to just continue this part here. So you can see everyone first, x1 plus x2 is equals to ft square by 2m. Remaining terms beta cancel each other here. So here, student, I can write this is x1 plus x2, x1 plus x2 is equals to ft square upon 2m. x1 plus x2, which is what, ft square upon 2m. Beta, there is we need to find your extension. So there is beta, what you can say, further extension what's the party, right? So you can say beta extension which is equals to what, x1 extension what's the party, you can write here over here. This is, student, step, I can say here 1, this is 2 beta g, this is 2 bacha. So 2 no beta, now just I'm going to continue, this is step 3 bacha party. Okay, so this is what beta, you can say extension x1 minus x2, which is nothing but it's x0. This is what, student, you can say x0 here, x1 minus x2 is equals to what, student, it's x0 only, because this is extension in the spring, students. Okay, beta g here I can write here for the further things, because x1 we got here, right? So beta, from equations we can write with x1 is what, x1 plus x2 is equals to what beta, the ft square by 2m, right beta? Okay, so just beta, just this two here, student, just do one thing, let us suppose equation number 1 beta, this equations number 2 beta, just subtract here equation number 1 and 2. Student, hello student, just subtract what's a party. So what you can see, this word twice of, subtract not here, add simply beta, add here equation number first and second. Student, you have to add equation number first and second. So you can write beta, this is twice of x1 is equals to beta ft square upon 2m plus beta, what you can say, x0, my dear. So you can write beta x1 is equals to f2 square upon 2m plus x0 into 1 by 2, my dear, into, student, 1 by 2, my dear, right? Similarly here we can write x2 also, because now beta, what I can say here, student, I added here equation of first and second. For getting x2 beta, what I'll do, just subtract here these two. So once beta, I'll subtract here these two, so we'll get here x2 from here only, x2 beta, what I can write here simultaneously. Similarly bacha, 1 by 2 f into beta t square upon 2m, this is what beta is, minus x0 here. So finally beta, will get here x0 and I can say x1 and x2. Once beta will get here x1 x2 here, so that is the point we have to find beta extension in this spring, that is x naught. What's x naught here? This minus this, because we got x1 x2, we got beta x1 x2 here, so extension beta will get from here only. Beta in third, what displacement of given block? Yes, this is Vichaji, displacement of given block here x1. Now student, this is the displacement of given block beta. I can another one here. So this is x1, this is what x2. Again, I'm going to repeat it. It's a good questions only. So listen beta carefully here. I can say there is student. I can say there is a two block, both connected through spring. You can see right block, there is a force applied which is constant magnitude. So we have to find displacement. So this is the displacement which is force remains constant here. Mass beta, this can apply simple formula ACUM. F total upon mass total which party will get ACUM then XCUM here. And finally beta just solve here, will get answer of the questions. It's not tough at all. Just do once at home again from yourself. So definitely beta I will get answer of these questions here. You can easily understand it if you enjoy beta this kind of numerical here, right? So now beta again here I'm going to use next numerical. Today beta class only dedicated beta only a collision. Entire class student dedicated to student, that is I can say collision, right? So next student questions here, just will go through everyone. I'm very happy to see all of you join live stream of physics point. The friction coefficient between the horizontal surface and each block is 0.2 shown in the figure. Beta here you can take care of what is the things. You can see student, this is the surface which has the friction. Student, there are two block. Student, there are two block. You can take a mass of one block which is equals to 2 kilogram. Beta, this 2 kilogram in motion here. You can take any data here. HR01, this is 1 meter per second. Now this is PN. This is PN meter. This is 2 kilogram. This is 4 kilogram, my dear. Okay. Let us see student, there is some initial separation or distance between the block which is equals to 16 centimeter. Now students, this is the things. Beta, God bless you for your reaction. This is mu student. Mu beta, you can take 0.2 everywhere, entire surface beta. This block also be surface 0.2. This block also be surface 0.2, my dear. Okay. The collision between the block is perfectly inelastic. Perfectly inelastic means there is no loss of energy, right? Okay. Find the separation between them when they come at rest. Okay. So finally beta, after collision here they will come at rest. So we have to find separation between the block. What is the final separation? You can take bacha for our easy calculations. This is 10 meter per second square. Okay, fine. So we need to find here. Find separation. Find separation between the block after perfectly elastic collision. Perfectly elastic collision. Okay, fine. Come with party. So, have a look at it. How can we do this question here? In step 1 beta, what is the things here which you can initially first step for these questions? Bachaji, if your particle initially in motion, they will come at rest finally. So you can think about retardation. You can think about retardation. So what is retardation over here? Who is culprit to create retardation? Friction force. What you can say? Friction force. So here student you can write here retardation. Which is equals to beta minus mu m g upon m. Mass remains a bit common here. So this is because this is initially at rest here. So I can see this block only beta phase retardation. So a beta minus here nothing here. It's what representing retardation here, or you can say deacceleration. So acceleration you can write, my dear, nothing but it's mu g. Acceleration you can write, my dear. This is nothing but it's mu g only. Mu beta point to mention here. G we can take beta tension here. 10 बच्चा बड़ी. So A finally will get here. This is 2 meter per second square. So I'm not taking here minus sign because minus already understood here. This is what acceleration is negative. Okay, velocity of first block beta. I can say velocity beta before collision here. Velocity before collision बच्चा बड़ी. So we can find here because we have acceleration and we have a displacement. So velocity of block we can find 2 kilogram after collision. Velocity of block beta what we can say after collision here, right? So let us suppose I'm calling it's v1. v1 square beta you can write this is u square plus 2s. So v1 square beta you already mentioned here, you can write 1 minus 2 into beta. A beta how much here? It's 2 only. And what about s? This is 16 which are. So you can write here this is 0.16. So you can see 16 bacha party. This is what 2 to the 4 here 0.64. So 1 minus 0.64 beta. What we can say? Tell here. This is 0.36 here. You can say v1 square will get 0.36. So v1 beta what will get here after collision? What is the velocity of this block after collision here? Nothing but you can say this is 0.3. Sorry. You can say bacha this is 0.6 meter per second. What my dear, you can say this is 0.6 meter per second here. Okay, now beta we can think about here momentum conservation. Now bacha we can think about what? Momentum conservation here. Okay, so step 2 bacha body. Now student I'm going to apply momentum conservation in step 2 here. So what you can say, momentum initial is equals to momentum final. Okay, so beta this is the momentum here which I'm going to write this block already traveled this much distance here because no how collision occurred if this block what comes to what close to 4 kilogram, right Bachaji? So I can write here this is twice, and what is the final velocity of this block? This is what beta we can say 0.6. So you can write my dear twice into 0.6 p to b2 here. So this is, let us suppose I'm calling v1 dash plus beta is 4 into v2. 4 into v2. Okay, fine. Now bacha here you can say beta v1 and v2 are the velocity of what? Because this two one. v1 beta it's a velocity v1 prime. It's a velocity of 2 kilogram. Beta v1 prime is what my dear? v1 prime student. v1 prime is what my dear? It's a velocity of 2 kilogram just after collision my dear, right? Beta this is what beta 4 v2 here. v2 is what beta you can say velocity of 4 kilogram. v2 is what beta velocity of 4 kilogram just after collision here, right? So here bacha buddy this will go through this here, right? So beta from elastic collision concept here you can simply say bacha I hope you remember here cases number 6. So because man there is, if you remember here there is cases 1 2 3 we can v1 v2 v1 more than v2, you can say m1 much greater than m2, then m2 much greater than m1. Beta from that concept here I can write this is what beta is v2 minus v1 prime. It's nothing here, it's basically v1. It's basically v1. Okay, so beta I can use here this result over here. v2 is equals to v1 plus you can say v1 prime. v1 prime here. Now beta will get here this equations v1 from here only. So v1 is nothing here, it's a 0.6. It's a 0.6 which just beta fill this entire value here. So 2 into 0.6 is what you can say 2 into 0.6 you can say which 1.2, which is equals to twice of v1 prime plus student This is 4 times V1 plus V1 prime. V1 here known for us students. You can say this is 1.2 twice of V1 dash plus beta 4 times of V1 plus 4 times of V1 prime. So here student you can write 1.2 twice of V1 prime. V1 here how much? 0.6. So 4 into 0.6 2.4 beta 2.4 plus beta you can say 4 times of V1 prime. Beta will come this side here. So you can say minus 1.2. So what you can say? Minus 1.2 which is equal to beta 6 times of V1 prime. So you can take here V1 prime beta I will get minus 0.2 meter per second. This is the beta I can say velocity of my dear velocity student for you can say 2 kilogram just after collision. 2 kilogram what my dear just after collision. Beta what you can say just after collision here. So what we wish to find here separations finally, right? So beta once beta will get V1 prime here, beta I can fit value over here. Beta V1 known for us here. So we'll get V2 also. So students, I am going to write here. I can say V2 value. Let us say this is what step number 3. So V2 is what my dear? V1 plus V1 prime. So this is V1 is what 0.6 here. I hope you remember 0.6 minus 0.2 beta. So V2 I can write this is what my dear 0.4 meter per second. Now here I'll get V1 V2 beta just after collision. Students, finally I got V1 V2 just after collision. Easily I can find here displacement. Easily I can find student displacement here. Okay, that is the things we have to find. Find separation between the block just after collision. So displacement here how can I find? Simple beta. You can say S1. S1 is what beta? You can say this is V1 prime. What is V1 prime here? What is the V1 prime beta? This is 0.2 beta. This is what 0.2 beta and V2 beta what we can say? This is what you can say 0.4. So S1 beta I can write V1 prime whole square upon beta what we can say 2a. So S1 student you can write here this is 0.2 whole square upon beta 2 into 2 2 to the 4 beta. So you can see this is 0.01 meter. Similarly students I can find S2. So this is what beta V2 square upon 2a. V2 beta how much here? 0.4. So you can see beta this is 0.4 whole square twice into 2 here. So you can see 0.16 upon 4 beta. So this is what you can see 0.04. S2 beta is 0.04 meter. So final how much separation we need to find separation here. So S1 plus S2. So this is 0.01 plus 0.04 here. So this is 0.05 meter. So this is you need to suppose to write answer of this question here. What is the final separation? This is what 0.05 beta meter, or you can say 5 centimeter, or you can say what student this is the 5 centimeter. Got it? Okay, just move on next question here. Yes beta, move on next question. Okay, what's question student? There is a plank. Yes beta. I can say previous question also good, and this question literally are very good. This question student literally are very good. This question bachaji literally are very good. Okay. So bachaji, there is a plank. Student, there is a plank. Mass of plank beta you can take 5 kilogram. This plank beta due to some support beta, this is what fixed. This is what fixed, right? Okay. So beta you can take mass of the plank 5 kilogram. Length of the plank beta, you can take, this is the 4 meter. This is the 4 meter. Beta, due to this support here, there is another block on the plank. Student, there is another block on the plank. There is another block on the plank here, which is 1 kilogram, which is 1 kilogram, right? This block beta connected through spring. Entire system beta initially at rest. Student, entire system initially at rest. There is no change at all. So now I'm going to read the question here. A plank of mass 5 kg is placed on a frictionless. There is no friction at all. Because you can see this plank placed on a surface. Right. So this surface is, students, you can take, this is a frictionless. There is no friction at all, my dear. Right. Okay. So student, for this condition here, what you can see, 1 kg placed over the block, a massless spring of length, natural length. Okay, without, as I said, there is no disturbance at all. So student, natural length of spring. Student, natural length of spring, that is 2 meter. Given, my dear, natural length of a spring, what student, you can say this is what, 2 meter, is fixed to the plank by its one end. The other end of the spring is compressed. Other end of the spring is compressed by the block by half of the natural length. Okay, Bacha, you can say in this question, I hope you got it. What is the velocity of plank when the block leaves the plank? Oh, very wonderful question, yaar. Superb, very good question. Very good question, yaar. Right, okay. So come to the point, everyone. Okay, so we have to find velocity of plank once this block leaves the spring. That is question here. The system is now released from rest. What is the velocity of the plank when block leaves the plank? Okay, beta, stiffness constant here. You can take K is mention of spring, that is 100 Newton per meter. That is what, my dear, 100 Newton per meter. Okay, fine, bacha party. So this condition here, we'll go through this. Okay, fine. So bacha, we'll go through this here, the questions. System beta initially mentioned here, initially I can say bacha, system is what, initially compressed half of this bacha. System, student, initially compressed half of its natural length, that is mentioned in the questions, right? So we can think beta, I can say initially here. Step 1, student, you can think about energy conservation. My dear, you can think about energy conservation, right? Okay. So Bachaji, here you can write here energy conservation. Because system has initial potential energy, which is spring potential energy, right beta? Once we'll release here, so particle attain kinetic energy in terms of velocity, you can say. So this is, students, from energy conservation, student, from energy conservation, this is half of kx square, which is equals to half mu square plus beta half capital M beta for Planck v square. That half beta you can say cancel everywhere. Student, this half you can say are happy body. So this is, students, you can say k x square is equals to mu square plus mv square. This m beta you can take for this conditional, students, right? So k bacha how much here? 100. K bacha ji how much here? This is 100 into x square. Mass beta ji 1 here you can see u square plus beta 5 into v square plus beta what you can say 5 into v square, right? Okay, so bacha ji for this condition here x what we can take, x beta what we can take, because beta x what means in x, what's it, yes, initially beta they compress beta how much, student uh, mm, okay, on ray optics beta I'll take SR01, but it will be late here. I'll take it around 10 o'clock, right? Because I'll beta stop this class, student 8:30. Then beta I'll go for something. Yes, okay. If possible, beta, then you can join here. I can say student around 10 o'clock. Okay, fine, bacha. So this is conditional which we'll get from here only, right? So E and V, bacha. So beta will get your first equations from here only. Next length beta how much mentioned here? That is 2 meter. That is 2 meter there initially, and they compressed how much? Half. They mentioned here in the questions. So I'm getting yes. So x beta remains 1 year only. So we can say beta this is 100 is equals to u square plus 5v square. Say equation number 1. Say student equations number 1 here. Okay, fine. Beta from energy conservation here, because what's in the questions last time here. The system is now released. The system is now released from rest. What is the velocity of Planck when block leaves the Planck? So beta we can think about energy conservation. Step 2, students. Already I applied here energy conservation. How many times I can apply? Next beta, momentum conservation here. LMC. This is student momentum conservation here. So what beta you can see this is m into u plus m into v, which is equals to 0. M here remains 1 year. So you can write beta u is equals to minus 5v. U is equals to minus 5v. Let us say equation number 2. Beta this one you can repeat over there. We'll get bacha v. This is we have to find here. What is the velocity of Planck just after released? So beta I'll feed beta in step 3, my dear student. I'll feed here further in step 3, right? So this is what student 100 is equals to u square. So you can say not u here, u beta minus 5. So it's what 25 v square plus beta z 5 v square. So you can say 100 is equals to what, how much here? 25. This is what beta you can say 30 v square. Kopach here. So you can write v is equals to root of 10 by 3 meter per second. Student, this is v here we got. This is what you can say velocity of Planck. This is what, my dear, velocity of Planck. This is you can say which velocity of Planck, right? Okay, so take snapshot here, everyone. Okay, fine. Next question is just we'll move here. Next question. We'll move beta. Next question here. Okay, I hope you have taken snapshot. Yes, beta. Fine. So now student. Yes, bacha ji. Beta Jai Shri Sham. How are you? Okay. So again, student. Will move beta ji next question here. Okay. So beta, what's the question here? Ball is projected from the ground with speed u at an angle alpha, right? It's a good question. Yes, beta, it's a good question, but will take some time. But I'll do. It's a good question here. Student, God bless you for your reaction. What is question here? I remember. This is, student, you can see fixed wall, right? Yes, beta. This is the horizontal plane. You can see this is the projection point. Beta, projection point means you can see this is what A from the wall, right? What's questions here? Very common question. I hope all of you remember here these questions. Particle beta basically what hits the wall. Let us say initial projection speed of wall u meter per second. This angle is what, my dear? It's alpha. This is a particular finally hits over here. Now beta this particular again come back, right? So this particular beta again you can write come back. So what we have to find basically, beta? Find coefficient of restitution between the ball and the wall, right? Find coefficient of restitution. Find E between ball and the wall. This one, I did this question in classroom here previously. So beta will go through this here, how functions we can think, right? You can say bacha, for entire journey here, particle will, I can see this is going and coming back, that is time of flight. So from here to here beta, we can take half of time of flight. From here to here beta, again we can take what, half of time of flight here, right? So you can take it, this is O, this is beta, you can take B. So you can see time of flight beta. Time of flight is nothing here. This is time of flight total here. So 1 beta O2B beta, and you can write here. This is something here. How can I differentiate? You can take OAB, time going for OAB, and now beta BCO. Yes, I can write like that. Then you can easily understand. So total time of flight beta. You can write total time of flight, time of OAB plus beta G, time of BCO. I hope you got it easily. I hope all of you remember your time of flight formula from 2D kinematics. I said multiple time here. This is 2u sine alpha by G, which is equals to what, my dear? This is half here. This is half beta party. So beta time is what? Here beta what we can say? Distance upon a speed. So this is beta distance here, and which speed is responsible here? So you know we can because this is what? U cos alpha, U sin alpha. So U cos alpha is responsible to travel this much distance only, right? So you can see bacha, this is what time is equals to distance upon speed U cos alpha plus. I hope all of you remember here, this thing I said multiple time in the classroom. A particle hitting, let us suppose this surface has a coefficient of restitution E. So I hope all of you remember here, a rebounding velocity E times of U initial. Again you can say, sir, this particle has at this point, I'll beta say here only, this particle has two velocity, one beta in this direction. This is U cos alpha. Another here, you can say this is U sin alpha. You can think here logically, who is responsible to, I can say, bounce back? That is here horizontal only beta, because this will hit the, I can say, wall like this bacha. So this is the velocity. A remains the same bacha. A remains same bacha because they are traveling same distance here. So this is A, and this is what? E times of U cos alpha. E times of what beta? You can say U cos alpha. Again I'm repeating it. This is the point beta which you have to definitely keep in your mind. What, my dear? time is total time of flight. This is, you can say here, time or AB for going. This is time for coming, bacha. That is BCO. This point here you can keep in your mind. If any particles is coming down and hitting the floor, and floor has a coefficient of restitution E, so final velocity, or you can say bounce back velocity, which is equals to E times of initial. So but I apply simply here. I hope you got my point. Now further, yeah, just we can go through here, just simplify the things, right? Okay. So what you can say, beta, I'll take this one this side, this one this side here. So you can say this is what a student, A upon E u cos alpha, which is A upon beta, you can say, this is this side, na? Okay, this one come this side. So S beta, you can say 2u sin alpha upon G minus here A upon u cos alpha. A upon u cos alpha. Beta, just take LCM here. What we can see u cos alpha. So you can say this is A upon E u cos alpha, which is equals to, you can say, G into u cos alpha. G beta you can take common here. So you can write 2 into what picture? U. 2 into what picture you can say? This is u squared sin alpha cos alpha minus here. This is what we can say AG. This is what we can say AG. You can say simply picture. Sir, u cos alpha finish. Yes, you can do beta. So you can write it as A upon E. This term, sir, you can just apply little trigonometric formula. It's nothing here. It's sine 2 alpha. So you can say this is u square sine 2 alpha minus AG upon G bacha party. But BB is to find E, coefficient of restitution. The student BB is to find what? Coefficient of restitution here. Just better do cross multiply. So you can say this is E is equals to I'll write here only. Just do the cross multiply. So you can say this is AG is equals to E times a student u square sine 2 alpha minus AG. So E beta finally you can write this is AG u square sine 2 alpha minus AG here. Beta you can take your AG common from here bacha party, and AG you can say kopach. So this is 1 upon beta u square upon AG sine 2 alpha minus 1. So this is an answer for the question here. Yes sir, it's a good question. It's a good question, my dear. Right. So this is I can say still I wanted to do more question because I'm just bounded with timeline here, so I'm not able to do more question based on this, right? But literally I can say this question and one blank question is literally it's a very good question. So everyone beta be remember here as a standard also, if possible for you, just will go through this anytime anywhere. You can watch this video, you can watch this session. I'll upload as usual same. So student, this is all about today class, right? I'll see student in next session. Now I'm going to stop live session.